Доброе утро.
Good morning. Good morning, everyone.
Спасибо большое, что пришли.
Thank you for coming here. This track was supposed to be opened by Vladimir Kochetkov,
Сами видите, какая ситуация с
but
проходами.
you can see how things are with the traffic. Okay, and so let's not wait for him. Let's be starting with this track.
Дал слайды.
Vladimir has passed on the slide deck to me. By the way, are you putting up the slides now? Oh, are these the slides? Okay, and do you have the clicker? Right, thank you. Sorry.
Сегодня, получается,
So today,
хотели, Володя хотел отметить
Vladimir
пятый год
wanted to celebrate the 5th anniversary of this track, this section. 5 years ago,
сделать такой трек,
an idea first came up to start this track
слиться
or this section
воедино,
where developers and security guys could come together and discuss some
и
topics of interest.
как раз это было
From both
сделано
sides.
то есть в свое время было создано это сообщество
And
Positive Development.
we created this group, which used to be called Baduk, it's now called PosiDev, for positive development. Anyway, I want to take an opportunity to celebrate the 5th anniversary of this track. Please join the community that we have for this track in Telegram. We post memes there on Fridays.
Да, и по поводу пятилетия этого трека,
And by the way, regarding the
позитиве,
5th anniversary, I'm not with Positive anymore. I work with Yandex Cloud at the moment, but still Vladimir and the organizers decided to celebrate the anniversary by reaching out to me to recall how this track first came up, to remember the good old days. I apologize for reading from my phone because I have the speaker notes here. Okay, I'm now with Yandex Cloud.
несмотря на то, что я уже другой какой-то компании, я
And even though I changed jobs,
все так же набирает огромные залы. Вот, то есть мы начали тогда, когда начинали 5 лет назад, было достаточно скромно, а сейчас, конечно, уже совсем другие масштабы. Я этому очень рад. Хотел немножко рассказать про историю, про то, как этот трек появился, как появился маскот этого трека. Кто-нибудь знает его? Видели? То есть если вот в телеграм-канал зайдете по этой ссылочке, то вы увидите вот это забавное существо. Вот хотел рассказать про то.
if you go to the Telegram channel, you will be able to see this mascot and to find out what it means. At that time, Alexei Goncharov, and I guess he's still on his way, suggested that we need a mascot. And why? Because when we do application security, and we were developing a static analyzer and our colleagues are still on it, it became clear that this analyzer I mean, not just for security guys, but also for developers. There had to be a conversation about it because they were the main users of the analyzer. So we wanted to create a movement around some secure development. And Alexei Goncharov came up with an idea of a mascot. And this creature became the mascot. And this is an animal from Madagascar. And you can see that we chose it for a reason. You can see that it has a long middle finger, which it uses to pick on trees and plants and holes to find insects or bugs. Pun intended. I hope you recognize it. No? Does anyone recognize yourselves in this image? So we thought that this is a lovely mascot.
под угрозой исчезновения.
And actually, it's
Посмотреть прямо в
a rare species. It's on the brink of extinction.
несчастье.
So we thought that it's an even cooler idea to pick such an animal.
Этот маскот, так,
So hence,
наверное, стоит рассказать про это, что
we chose it, and I thought it's a good idea to share it,
немножко
share this story,
теперь
so
по
that we
поводу,
started having fun.
как участвует Яндекс.Клауд.
Okay, so how does Yandex.Cloud participate in all of this? I left Positive Technologies several years ago, but I'm very happy that this community continues to live on. The track is developing, and we are very happy that we are partners in this track.
Что хотелось бы сказать, что
And
то есть вот в Яндекс.Клауде очень
at
заинтересованы
Yandex.Cloud, we are very interested
людей, которые занимаются
in
как раз образованием.
having an increasing number of people who do secure development. Hence, we developed this course, DevSecOps. It's free, and
Мы в него вложили очень много времени и средств.
I'm fine with it being free, although we invested quite a lot of money and energy into it.
Ну, то есть для чего хотелось бы...
You're welcome to register
Для чего
for
я
it.
рассказываю про этот курс?
And why I'm talking about it
Я уверен, что большинство из вас
at this track, I'm confident that
серьезные профессионалы в этом.
many of you are already well-established professionals, and this course is for beginners. What we see at Yandex.Cloud is that people like you, there's only a handful of these.
Достаточно редко можно найти людей, которые
They are hard to find, those who know both about security and development. So the solution
нужно привлекать смежников.
for having more and more secure apps is to bring in others into this orbit, to bring in those who are still quite remote from security, who do security but don't do development. And hence the course.
Его, пришлите его, пожалуйста, своим коллегам.
Please forward this information to people you know who you think might be interested.
Да, вот здесь вот Володя должен был рассказать.
Okay, and here Vladimir,
Сегодня же пятница, и
the original speaker, who's not here,
в сообществе есть традиция по пятницам.
was supposed to
Мы сделали
remind you that on Fridays in our Telegram community we post memes, and Vladimir was supposed to share with you a funny story about Application Inspector. I'm not Vladimir, I'm not trying to match his humor, so let's just take a look at these memes and appreciate them. Okay, so we post them every Friday, and again here there was supposed to be another story that something went wrong on Friday.
Я думаю, выложим в телеграм-канал.
We'll post all of these memes on the Telegram channel.
Киберриски.
Cyber risks. And this is you, by the way.
Да, тут реклама круглого стола.
This is
Индустрия.
an announcement of a roundtable, the future of Russian high-tech industry. And by the way, a colleague of mine from Yandex.Cloud will be participating. You're welcome to join. It's supposed to be fun.
Мы будем раздавать гранты в Яндекс.Клауд.
We'll be also
Яндекс.Клауд.
offering grants from Yandex.Cloud for the best speaker. So please follow the QR code, vote for the presentations.
Я думаю, что да, и по результатам этого голосования
And following the results of this poll, we'll give grants to 3 best presentations.
Дима, да, ну все, в принципе.
Okay,
Я объявляю этот проект открытым.
I now declare this track open. Let's begin.
Тогда через пару минут или не знаю, или сейчас уже.
Okay, in a couple of minutes, or shall we do it now? Okay, let's do it now. Dmitry Sklarov is our next speaker.
Спасибо. Давайте все-таки дождемся.
Now, let us wait until 10 a.m. sharp so that everyone will start listening from the very beginning.
Чего?
Just,
Работает нормально?
Thank you. Well, you saw the previous slide with QR code. Join the community. You will find a lot of interesting things for you. I am Dmitry Sklarov. I am head of application analysis department in Positive Technologies, and it's a great honor for me to open the track in the area where I don't work. I have not been a developer for the last 10 years, but before that I wrote some codes. I have experience, but in the last 12 years I was in reverse engineering, and this is what I like very much. This is a great driver for me. I am very curious, and I try to find out the structure of what I work with. And I'm a professional paranoid, and I try to find some hidden things everywhere. What can be wrong here? This is my mindset. And I chose security, protection, defense, rather than attack. That's my job. I've been in PhD conferences every year as a speaker. Then I joined Positive Technologies, and here I am. I'm not going to teach you how to generate code, how to make it secure. I am just going to talk to you about my personal experience, what I see when I analyze somebody else's codes. Why are there errors in those codes? What people do with such code, and how can we live with all that? Sorry. Well, part one, where do the errors come from? This is a very simple definition. Errors in source code is a result of our struggle for efficiency. We're talking about applications which are aimed at the market. Of course, there are some programmers who generate code just for the sake of code, but other people want to earn some money, raise prestige of the company, of his personal prestige, and the more efficient they are, the more money they earn. Who is the efficient programmer? Of course, the efficient programmer should be not expensive. He should generate code fast. It should be simple to read and modify. It should pass all the tests, and it should consume as few resources as possible. And of course, this is a classical picture when you need quality, speed, and low price. So one of the three should be your priority. And first of all, we can sacrifice resources. Java had 4 megabytes. It needed 4 megabytes, but computers had 512 kilobytes of memory. But this is a problem of a user. Buy better hardware. Then tests. Let us reduce the test workload because tests require resources and time, and we must work fast. Of course, if we cannot modify the code easily, but we can live with it, well, sometime in future we shall hire a bright person who will change it. And then, of course, we cannot find cheap programmers. And then the only thing we require, we must generate codes fast, and the code must solve the problem. This is the main thing, the only requirement. And why does it happen? In IoT, S means security. Historically, when companies started entering IT market, they were so in a hurry, in such a great hurry. They didn't think about quality and security at all. And this is a normal approach when the market wants something fast, when the company offers something brand new. When the programmer generates a code, he can test it in different ways, but it takes time. Anyway, each additional test requires the programmer's time. If we overload the programmer with tests, then he wouldn't have the time to generate good applications. And in the environments where the program was generated, it should work all right. You don't have this file, it's your program, it's your problem. The program works. Perfectionism is one more thing typical of me. It's both a positive and a negative point. Perfectionism is harmful to me. I continue working with the code even when the code is ready for the market. And well, the probability of finding more errors later on is rather low, but I still try to find as many errors as possible. But very few people use this approach, and errors are normal. There are a lot of tests, reviews, and there is no problem. So people make mistakes, people generate errors. I try to fight it. Bruce Schneier said once that if you come to an engineer who builds bridges, And if you ask him, did you calculate the stability of the bridge? Yes, of course. But what if the wind blows from top to bottom? Do you calculate that? He would say, am I crazy? It will never blow from top to bottom. It will blow sideways or along the bridge. But in IT, we should take into account all possible situations if you want to get the secure code. But this is not efficient, and very few people do it. And why are we going to generate code which has already been generated? 95% of the code is already available. In Stack Overflow, you can find a lot of things. It's something like taking information for your scientific research from Wikipedia. Stack Overflow is not a secure and stable source of the code. If you copy-paste the code, even your own code, from one place to another without thinking of side effects, well, this is what happens very often. So this is what I saw when people made errors. Now, let me tell you how people try to eliminate those errors, for them not to interfere with the product. The first thing which many people use is what is called mitigation. Mitigation is the reduction of severity and seriousness of error. It softens the result of the error. For computing, for IT, we see a lot of mitigation resources, mitigation methods. The first one is stack canaries, the attempt to see that the stack was broken in order to prevent unacceptable actions. Maybe the program just fell down and it's not fatal. The other thing is when somebody did it on purpose. Stack canaries cannot protect you from breaking the program, but it might protect you from some insecure, undesirable actions. For example, data execution prevention is the hardware method. You have to develop a new processor to do it, but all those solutions have two main descriptions. The first description is that they do not solve the problem. The code will still contain errors. If you use a different compiler, you will have bad consequences. And the positive thing is that it doesn't cost anything for the programmer, because all that is done before you do it. The programmer continues to work as before, makes mistakes, but the number of mistakes becomes lower. The program works better. The application works better. People started to think that we have to find the errors as such, not to mitigate them, but to find and eliminate the errors, to localize, find, detect those errors. When I went to Google, I knew what lint is, but I didn't realize that it exists since 1978. Very few people are older than Lind in this hall. For more than 40 years, people tried to detect errors automatically in the code. When we talk about large-scale development, Microsoft 20 years ago, when they started fighting for security, the first book that I read about secure development, LeBlanc and somebody else, Secure Code was the book, was the name. And Microsoft started entering the warning in the compiler. This function is not secure. People often make mistakes. Use fprint_s. They offered a new set of safe APIs, and code became more secure, although the programmer can disable warnings. But still, Microsoft stimulated developers to make fewer errors. Vladimir Kochetkov and many other people try to develop analyzers, static, dynamic, interactive, and so on, which help us to take the real program, existing program, analyze it, execution, predicative and non-predicative things. I don't understand the way it works, but it's very cool, and they give very good results. Sometimes they produce too many false positive. If the code consists of 100 strings and you get 500 false positives as a result, that's bad. But I support this approach. One more way which brings about good result is the change of the programming language. There is a classical dispute that this is a good language, this is a bad language. Of course, there are some languages which are good for some things and other languages which are good for other things. I recommend Programming Pioneers book. It's the interviews of the developers of 20 popular languages, and they explain why they developed their language in exactly that way. For example, C. C is for high speed. Java is focused on security. If you can skip a lot of things, but Java forces you to do it. Otherwise, your code will not be compiled. So you are forced to control. This is part of the concept of the language, and this is good if you generate software, corporate software, enterprise software, secure and stable. And of course, there are a lot of characteristics there. Typization, managed code, .NET and Java is managed code. C is native code, non-managed. In native code, you can easily make a mistake. In managed code, you cannot just write whatever you want. And therefore, managed code is more secure as a final result. It's better to check syntax very strictly. I like Python very much, but I'll never generate production code because I wrote a brute forcer for 24/7 and I saw an error in the name, and the program fell down and I had to redo it. Other languages like C can skip it. And the name, I could, name of the variables. Proof of concept is the code which will never guarantee stable work. It should work once, And there is a theory when sometimes functional languages help. I'm not a mathematician, and I cannot think in the terms of functional programming. I talk to the people that Haskell should be used all the time, but Haskell can also generate a program. You can find 3 programmers who know Haskell, but if you want to find 10, you wouldn't find them. 10 Haskell programmers who can change the company. So you don't have such a great number of Haskell programmers in the world. There are very few of them available. And the idea is that when you choose a language, you shouldn't choose the best language which would solve all your problems if you don't have ready-made programmers knowing the language. Because if you know C and you want to use PHP, it's easy, although I don't like it. But if you know C and you want to teach him Haskell, it's very difficult because Haskell is quite different. There are some write-only languages which I like very much. This is the Perl language, which deciphers data which was encrypted for DVD. When DVD discs were produced, they were different. One for North America, the other for Asia. And of course, this is the program which makes it possible for any disk to be used in any regions of the world. Of course, if I go back to the Programming Pioneer book, it shows you very well the difference between Perl and Python. In Perl, you can use any kind of methods to do anything, and they will offer you anything. But Python will offer you only one, the intuitive one, and the second approach is better. That's why Python programs are very easy to read, easier than C, although I've been using C from 1994. And Python I use for the last 15 years only. Now, write-only languages. When we use a language, we know the program from the beginning to the end. But if you take somebody else, the person doesn't know the program from the beginning to the end. He learns the program in stages, step by step. Sometimes I read the programs in C, C++, and I don't like C++ because C++ is the write-only language. What is the problem? When people write a call for a function, I try to call a method or a class. When I use C, I use a very simple method and see where the function is realized, to go and see what happens. When I have C++, I have the name of the object, the arrow, and the name of the method. It may be not a class, it may be an interface implemented anywhere, I don't know where, and it's very difficult to find it. For example, sometimes I look at cryptography, and if I know the name of the algorithm and I want to see the code, how it works, I have an OpenSSL and script C++. The algorithms that are implemented are good, but in OpenSSL I will find the file from the second attempt and I see the code. In OpenSSL, I find it from the fourth or the fifth attempt. It's and it takes a lot of time before I find the implementation itself. It's a complex and a bad process for me. I don't like it. I found an interesting description. The book was for the Russian audience. People learn OOP before learning OOP. OOP is the object-oriented programming. But there is an object-oriented programming and the object-oriented projecting. Object-oriented programming is okay, but when people don't know what object-oriented projecting is, it's very difficult. If I name different things in one name for different things, and some people do it, and the program will work. I don't know why they attach the same name to different objects. The implementation is hidden in that way. Two functions with one name should do exactly the same thing. But if the arguments are the same, one int, the other float, if one takes one argument, if the other takes two, it's strange. I don't understand it. And a lot of code contains errors because the people are mixed. People don't understand what is hidden under this name. For a certain extent, to a certain extent, you can keep it in your mind, but then it's too much, and you make logical errors. How do people maximize security of their program solutions? You know what defensive programming is and secure coding is. You try to think about everything, but I'm going to talk to you about secure execution. I met two kinds of secure execution. The first one is simpler. You have a program and it can be executed in 3 calculators, and each time the results are compared. If 2 coincide, then the solution is valid. If 3 coincide, it's okay. But if there is an error in one, then we just skip it, delete it. Mumizon came in, and the electron is kicked out of the memory cell. It's all right. So if 2 results are good, 1 not, we delete the third one, and the 2 are all right. I saw it in railway security automation. There is the Sternol language, almost extinct. IBM is the owner. It was generated in Sweden. It describes railway security. Sternol compiler generates 2 sets of rules which check, after changing the situation, is there any probability of accident. They take OPC and ARM, they compile the code generated by Sternol preprocessors, they generate a C program, we compile it, and in one box pack the system about changing the routes. We have 2 calculators, independent ones, with different architecture, in different procedure, checks all the rules, and each of them generates the result. If both of them say it's secure, so the signal is changed. If the solutions are different, then nothing is done, all the trains stop. Of course, that's expensive. Even when 2 parallel systems work like that, it's expensive. 3 is even more expensive. And of course, people invented SDLC. I don't know anything about it. I'm not a developer. I can afford it. And at a certain extent, at a certain moment, I saw that I used it from in the last 4 years of senior school. It's a College of Automation and IT. in First Parkovaya Street in Moscow. It was 1987, 1991. Once a week, I had access to a computer. I am from the IT family. My father had a huge computer, 100 square meters. However, now the present smartphone is more powerful than that computer of 1970s. Of course, we didn't have a computer at home. Radio RK, Mikrosha appeared, but they they were not good, not affordable. But once a week I went there and used Agata. Then DVK computer, it was worse than Agat. And then in the last years we had IBM PC XT. I had access. And for example, we generated eternal calendars or sine and cosine charts. Nikolai, my friend, changed any figure in different calculation methods, binary, tertiary, and others. I was heard and said, Dmitry, you maybe may generate a good program, but there is no sense. First, you have to write block diagrams and then the programmers. Of course, I got my diploma. I didn't realize why my program was criticized. Of course, they were teachers, I was a student. After 4 years, I joined the Bauman University, and one professor said, you were right and they were wrong. Of course, there are some tasks of code check when you look at block diagrams and see the block diagrams, and if they do not coincide, the program is wrong.
Человека, который в разработке.
I don't know anyone, though, who would develop diagrams before writing a code. But I do know about SDLC, and I think that's quite useful. And the last one section, why don't errors go away? Why I keep finding them in the code that I analyze? I talked about various ways of inspecting codes, of finding this and that in the source code. So here's the book. The first fact that I want to mention, 1996, and it's 368 pages, and it's about one operating system and one topic. It's about multi-threading applications. Everyone writes multi-threading now, but to do that in just one operating system using available tools, you've got to read a book of 368 pages. Of course, using static analysis, it's not possible to inspect using threads, because threads are dynamic. In dynamic analysis, guaranteeing that software is error-free, I don't think there is any guarantee for that, and people will keep making those mistakes. And to address such problems of correct multi-threading, it takes a lot of learning. I don't know how to teach people about it, but this is something that you cannot automate, this type of check. Cryptography, likewise. Cryptography is a call of a function. So how is a cryptographic problem different in other areas of code? You can't see it. What's a non-functioning program? You launch it and it crashed. What's a bad cryptography? You encrypt data so that anyone can decrypt it. But here you encrypt and you can't decrypt it. However, the program works okay. When I wrote my dissertation, I analyzed dozens of ideas how to protect a PDF, and the idea was like this: calls of cryptographic functions, MD5, then MD5 update with a constant and with another constant, and then all of that is converted into hash, and then this hash is loaded into RC4 algorithm. Then this key is used to encrypt data. What could go wrong? Where can you make an error? Does anyone know? Exactly. We feed we feed a constant into MD5, and so essentially the outcome is a XOR with a constant that's as strong as your encryption is. Yes, this can be found, but you've got to keep this picture in your head. If one programmer writes it, the other coder does a code review, they need to think about it in their head and say, look, an error is here. I find it in runtime. I can't find it in source code. I don't know how to find such things in source code. Likewise, with Adobe, I had a personal funny story. I had a few, but one was as follows. I worked at LPM Soft, and apparently in SDK there are plugins with weak signatures. It was possible to modify the plugin without destroying the signature. We reported that back in 2003 to CERT, and from CERT to Adobe. Adobe responded. To create such a plugin, you would have to violate an SDK license. So that's not a security issue, that's a licensing issue. And that's the end of it. So, and we were not able to achieve anything. Next, what about fixing vulnerabilities in real time, in a real enterprise? We went to a Black Hat conference in London, and we talked to Siemens security guys, and they said, look, your company sends us a lot of reports on our equipment, and they are good, and we understand, but look, fixes are only available in 12 months' time, and it's not us to blame. You send us a report. In a week's time, we look at it, we see that it's a serious issue, and report to development. And 1 week they don't respond, 2 weeks they don't respond, 3 weeks they respond and tell us, look, we're so busy with the important release that we cannot handle this. Wait until the end of our next cycle. At the end of that cycle, and that's 90 days, development tells us we've got a backlog which is huge. That is why we cannot take on a lot of new tickets for this cycle. Let's wait for the next cycle. The next cycle, they take it for development. After the next cycle, they release the tested and fixed version, and the vendor would publish a patch. That's when people can download it and install. And roughly in a year's time, after the vulnerability was reported to the vendor, users finally get the patch to address the security issue. This is not a coding problem, it's an efficiency problem, and we're back to where we started. In almost every big solution, it works like this. I know two companies that fix bugs quickly, Microsoft and Apple. They just invest themselves, they apply themselves to it. But for others, it seems that it's not that important. They go at their own speed. And there are many instances when we report that there is a vulnerability, and the vendor is really half-hearted in its response. It is reported that in the first 5 years of SAP, they responded, okay, and so what, there's a vulnerability, but customers would not walk away from us because of that. Fixing this vulnerability for them would be more expensive than the maximum loss that they could incur. Or home Wi-Fi routers. In 18 months' time, it's no longer made and it's no longer supported. You find an error, you report it to the vendor, and the vendor tells you, okay, go and buy another version. So the router works for 10 years, but if you don't upgrade the software, very likely there is a vulnerability through which you can be hacked. And often in software licenses, it is said that if you want to do reverse engineer products, you are not allowed to do it. So if you find a bug through reverse engineering and report it, the vendor has the right to ask, how did you find it? There was an article on Haber, and the authors said that because the vendor prohibits reverse engineering, everything that's written in this article we saw in our dream. But the funny thing is when a vulnerability is reported by a representative of a company that supports responsible disclose policy. At Positive Technologies, we try to never harm our customers because errors in software do not affect the vendor, they affect the customers. If we find a vulnerability and we report it the same day and it starts to be exploited by hacking systems, it's not the vendor who suffers, but it's good people that suffer. We try to wait until the time that the vendor fixes, and only then we report the vulnerability. But the vendor understands that if we didn't get information about the patch that has been released, we wouldn't write anything. So until the time they don't release the patch, nothing happens and they're protected, and they never release the patch. You see the logic? So if you come across Project Zero from Google, they wouldn't wait forever. They don't have such a policy. They would give you 90 days and they would publish in 90 days. Whether that has been fixed or not is none of their concern. The clicker doesn't seem to work. Okay, and a classic problem that you cannot find with any analyzer is business logic. I guess any coder has seen this meme at least once, and it's really a funny story, but there's one issue though. I believe that the answer here is not 10 or 11. And I guess there is at least one person in this audience who will support me. So what's the problem with the logic here? There's a full stop here. And I think that when a problem comes here, it's sort of has been through a certain piece of code, and it has to be there. So one piece of bread you would have to buy, but there's the second part, and this is not where everyone agrees, and this is the difference between reverse engineer and a programmer. A programmer operates abstract entities, and they just know how it should be working, but when I analyze the code, I refer to the real issue. Okay, so this simple program, from the point of view of logic, is it a legitimate program? So here I have a signless number. If I subtract 1 from 0, what would happen? So I know how it is structured within a processor, but for a programmer, in a positive number, reducing below 0 is not possible. But I guess 99% of languages would allow it. And what would be the number? What would be the value of I then? It depends on the compiler, it depends on the processor, it depends on internal presentation. When I was preparing these slides, I found information in Wikipedia about the resolution of processors. There's 8, 16, 32, we know about it. What about 31-bit processor resolution? And how would a program behave on a 31-bit resolution processor? We don't know. And the beauty of coding is that a programmer is not supposed to know about it, but then they shouldn't write a code that would behave differently in different systems. And that's the classic error theory. If an inexperienced person doesn't make errors, then maybe those errors just haven't been found. Errors could hide in various places. We have talked about errors in code that the programmer made that wrote the code that we execute. But there could be an error in the compiler, there could be an error in the runtime environment, and that happens quite often. If you take take Java errors, for example. Those have been exploited, and the possibility for the exploits was not because the programmer wrote a bad code. It's a managed language, after all. In the operating system, and Microsoft would try to patch them every month, and there could be an error in the driver of a device. My friends had a problem when the server crashed when the 20th customer joined, and they have really got to Microsoft to address it, and it turns out that there was an error in the driver of the keyboard, and for some reason that caused the server to crash. There are errors in the processor, and a while ago we did our research for ME. But aside from ME, Intel has many other entities which are not very clear how they work. We have some idea, but it might be different because there's no detailed information, and even us reverse engineers, we cannot check it. And so, as we approach the end of my presentation, what's to be done with all of that? I must say that I'm okay with all of this. The more errors people make, the simpler my job is, the more fun it is. I wouldn't be bored. So thank you, lazy coders, for being what you are. But if we were to provide some recommendations on what could be done, if you want to write good code, managers have got to understand that you have to sacrifice the effectiveness of business processes. Using just technologies, SAS, DAST, etc., just that will not save the industry. You've got to invest in the culture. Programmers have got to understand what it takes to write good code. And you should also use positive development. You should use positive, and you should be good. Thank you for your attention. There's a survey that you can take. Thank you, and if you have any questions, you're welcome to ask them. Can we have the microphone? Good morning. I wanted to build on the idea that the business has to modify its business processes to eliminate errors. Say, I've got a module being developed, 2 people working on it. If I want to address errors, I've got to take a third person, and that's a 50% increase in budget, and that means the price would go up by 2 times, and that's not good. My product wouldn't sell. So what do I do? You're asking the wrong person. I'm not a manager. I don't know how to address it. I'm a reverse engineer. That's what the problem is. That's not my problem. I just highlighted it. That's just my ad. The scooter is not mine. Okay, do you have an idea? No, because I'm not involved in development in any way. Okay, thank you. Okay, either you are bored or everything is clear. Oh, we have another question there. Yes, hello. My question is a little bit off the topic on cryptography. You say that in post-production and the dynamic environment, you can see how the cryptographic algorithm works and how strong it is. Okay, so we've done a statistical analysis and differential analysis. How else can we validate that the encryption works? Answer. Okay, you know that there's only one encryption that has guaranteed strength, and that's one-time notepad cipher. Everything else is not guaranteed, and the strength of cryptography is based on expert assessment. You give your algorithm to anyone you can reach out, and if they don't find a problem, they say, we don't find a problem, and you should be careful with the language. It's not that secure. It's not that we haven't been able to find a problem. Hi. I have a girly question, sort of. Okay, first it's the coder, then it's reverse engineer. What goes next? Okay, reverse engineer can be eliminated. You know, the fact that reverse engineering is there doesn't prevent software from being sold. I had a chat with someone who tried to explain to me that I'm actually a tester, and yes, that's what I am. It's just not the type of errors that you can find with other more automated tools, or the QE department for that matter. I am a QE department of some sort, just much more expensive. Okay, thank you very much for having me. Welcome to PH Days, and I wish you all the best in your job as developer.